So in 1987, International Astronomical Union and International Union of Geodesy and Geophysics established IERS, and that is International Earth Rotation and Reference System. So the main goal was to serve the astronomical, geodetic and geophysical communities by providing them with celestial reference frame data and terrestrial reference frame data. But why these two reference datum is required? We already have a WGS84 system in place. You see, WGS84 is purely terrestrial and does not provide enough reference of how the earth is rotating and deforming due to the tectonic plate movement. Our GNSS reference stations, they change places as the earth crust moves. The satellite orbits are being corrected due to this on a daily basis. We also need to monitor the rotational and angular velocity of Earth, as it greatly affects our positional accuracy. And what about space rockets? You don't want your multi-million-dollar moon rocket to head for Mars, do you? So when you try to observe and measure the motion of the Earth, it must be referenced accurately. So the Earth's crust movement and the rotation of the Earth in the space is measured with respect to a frame tied to a celestial bodies like a pulsar or a quasar. And this is celestial reference frame. There is something called Earth Orientation Parameters or EOP that connects these two celestial reference frame and terrestrial reference frame together. They provide a common reference to compare the observations and results observed from many different locations. So ITRF is a global geocentric 3D reference frame, and it is also rotating with the Earth crust in its diurnal motion in space. The origin of ITRF is the long-term average of the center of the mass of the total Earth system. Simply saying, that is with all its ocean and the atmosphere. So you may ask how you measure the geocenter of the total Earth system. This is done by satellite laser ranging or SLR. I'll explain about SLR later in the video. X-axis of ITRF passes through the zero longitude, or you may say Greenwich meridian. Z-axis is directed towards the conventional terrestrial North Pole, and Y-axis forms a right-handed coordinate system with X and Z-axis. Well, you can say that this sounds like WGS84. Yeah, kinda. But ITRF uses Geodetic Reference System 1980 or GRS80. And there is a slight 1 mm difference with WGS84 in semi-minor axis or the polar radius. 1 mm doesn't sound much, but that 1 mm makes a lot of difference into calculating the flattening of the Earth. And as we get more and more tracking data, the ITRF is being constantly updated, and the latest being 2020. But don't get excited yet. Present 2020 update is not yet implemented, and some of us are still stuck with ITRF 2014. We have 4 main techniques that contribute into defining ITRF on a global scale. Number 1 is GNSS. Yes, GNSS satellites and their positioning system plays a major part into defining the ITRF. Then there is this very large baseline interferometry. There are large arrays of radio telescope strategically placed around the Earth. And these radio telescopes, they observe the signals from the faraway quasars and pulsars which are beyond our own galaxy. These telescopes observe minute delays in observation from one telescope to another, and then correlate them together to form a reference frame. The third one being satellite laser ranging or SLR. There are a network of ground stations which bounces lasers onto the satellite and also to the moon surface. Can you believe that? Yes, and the time delay is measured very accurately, taking into account the rotational and angular velocity of the Earth as well as the velocity of the satellites and the moon. This is one of the most accurate technique to find the position of the satellites as well as finding the temporal variations in the Earth's gravity field and its geocenter. And lastly, we got DORIS. It's a French satellite system and the full form is Doppler Orbitography and Radio Positioning integrated with satellites. There are 60 something ground based stations all over the Earth and they emit a microwave signals which are received by the satellites. Please don't ask me what happens and how it happens. I'm not French and I'm not a rocket scientist. But all I know that DORIS is a little bit less accurate than the SLR and the GNSS system. Not by much, and they all contribute into framing the frames. Yeah, so the next time someone mentioning the flow of the glaciers, the coastal erosion, the tectonic plate movement, or earth climate, or even flipping of the poles, and you know that they all are tied to ICRF and ITRF. So there you go. This is all I have on ITRF. Not satisfied yet? Please check out the links that I provided into the description. Happy reading, and as always, stay curious.